Welcome back everyone. I hope you are doing well. In this lecture I'm going to solve a column design problem, and the question here says that design a square tight column, rectangular tight column and triangular tight column to support this load. Dead load is equal to 140 kip and live load is equal to 200 kip. And initially we have to assume the percentage of steel equal to 2%. That is, rho is equal to 2%. And the material properties are given as Fc prime equal to 4 ksi and Fy equals to 60 ksi. So first we have to calculate the factor load or the ultimate load, which is basically the summation of the product of service load multiplied by certain load factors. And Pu in this case, since only axial dead load and axial live load are acting on the column, Pu would be equal to 1.2 dead load plus 1.6 live load. Service dead load PD is equal to 140 kip and service live load is equal to 200 kip. So substitute the values here and calculate Pu. And Pu is equal to 488 kip. The second step is to calculate the gross area of section, which is basically the summation of the area of steel and concrete in the section. And we will use this equation to calculate the value of Ag from here. And since we know that the percentage of steel has been given to us, so we can use this relation. Percentage of steel is equal to AST divided by Ag. And if I calculate, take out AST from here, this equation becomes, and since rho is equal to 2%, so 2 divided by 100 into Ag, which is equal to 0.02 Ag. And we need to substitute 0.02 Ag in place of AST. So this equation becomes and substitute the value of AST here. And Pu is equal to 488 kip. So we can see here that we have an equation with only one unknown, that is the gross area of section, Ag. So we can calculate Ag from here, and it's coming out to be equal to and if you simplify it, Ag from here is equal to 207.07. And this is the gross area or the total area of the section needed to resist this load when we assume 2% longitudinal steel in the column. So first I'm going to design a short square tight column. So let's assume that each side of the square is equal to A, and the area of square is equal to A square, A multiplied by A, which is equal to A square. And now you need to equate area of square with the gross area of section. That is, Ag is equal to A square, and Ag is equal to 207.07. And if you calculate A from here, A is equal to 14.39 inch. And to make it practical, let's approximate it to 15 inches. So the Ag used would be equal to 15 multiplied by 15, which is equal to 225 inches square. Now the fourth step is to calculate the area of steel. Now you might think of using this equation here, but you can only use this equation when this Ag is equal to this Ag used. But this is not the case here. We have increased the area by a certain value. Here Ag is equal to 207.07. and AG used is equal to 225. Now to calculate the value of AST, that's the area of steel, we will use this equation again. PU is equal to 488, phi is equal to 0.65, K is equal to 0.80, FC prime is equal to 4, and AG here is equal to AG used, which is equal to 225, minus AST, which is the unknown in this equation, and now you can see that we have only one unknown in this equation, which is area of steel, and area of steel from this equation is equal to AST from here is equal to 3.064. Number of bar is equal to AST divided by the area of single bar, and area of steel is equal to 3.064, and let's assume that we are using number 8 bar. So the area of number 8 bar is equal to pi upon 4, 8 by 8 square, and the number of bars n is equal to 3.901, which means that we will use 4 bars of number 8 in the column. And the last step is to calculate the spacing of ties or the transverse reinforcement that is to be used in the cross section. And let's assume that number 3 bar acts as a transverse reinforcement, and the spacing of tie is the least of 48 dia of tie, 16 dia of longitudinal bar, and the least lateral dimension of the column 48 dt is equal to 3 by 8. Since we are using number 3 bar, and the dia of number 3 bar is equal to 3 by 8, and this is equal to 18 inches. 16 dia of longitudinal bar. Dia of longitudinal bar is equal to 8 by 8, and this gives us, and the least lateral dimension of column, since both of the dimensions are equal, is equal to 15 inches. And since this is the lowest value here, this will go on. So spacing of tie is equal to 15 inches. And in the end, let's draw the profile of the column that shows us the spacing of ties. So these are the longitudinal bars for number 8 bar, and these are the ties. And the spacing between the tie is equal to 15 inches. And in the cross section, the transverse reinforcement would wrap around these longitudinal bars, would laterally support these longitudinal bars. And now we will design a short rectangular tied column, and the data as well as calculation up till here will remain the same. And to start off, let's assume a rectangle, and the area of rectangle in this particular case would be equal to A into B. And if we equate area of rectangle to this AG, we would have this equation here. And it's entirely up to you which value you assume, A or B, it doesn't matter. In this case, I will assume B equals to 12 inches and calculate A on the basis of that. So A from here, from this equation, is coming out to be equal to 17.25. And let's approximate it to 18 inches. So the cross section that we are going to use, AG used, is equal to 12 into 18, which gives us a value of around 216 inches square. Now again, we will follow the same procedure. We will calculate the value of AST as we did in the previous case, and we will use this equation again. Alright, so we have this equation with one unknown AST. We can simplify it and calculate the value of AST from here. And AST from here is equal to now to calculate the number of bars on the basis of that area of steel. Number of bars is equal to AST over AB, AST 3.60, and the area of, let's assume that I'm using number 7 bar. The area of this bar, number 7 bar, is equal to pi upon 4 7 by 8 to the power 2, and n from here is equal to 5.98, which is equal to 6. And if I draw these bars in cross section, we have one side of rectangle equal to 12 inches and the other side equal to 18 inches. So there are 6 bars, 4 at the corners. At each and every corner you need to provide a bar, and the additional bars can be provided in between those bars. And now let's calculate the spacing of ties. Spacing of tie is the least of 48 dia of tie, and dia of tie number 3 bar is equal to 3 by 8 inches, and it gives us answer equal to 18 inches. And the other condition is 16 dia of longitudinal bar. Dia of longitudinal bar is equal to 7 by 8 inches, and this gives us a value equal to 14 inches. And the last condition is the least lateral dimension of the column. And first of all, these are the lateral dimensions, 12 inches and 18 inches, and the least of these dimension is 12 inches. And since we have to take the lowest value among these values, this means that this one governs. So spacing is equal to, the spacing of ties is equal to 12 inches. And in the last video related to column, we talked about laterally supported bar, and if this is spacing, clear spacing between a laterally supported bar and a not laterally supported bar, if it's greater than 6 inches, then we need to provide an additional tie. We need to tie up these unsupported or not laterally supported bars. So let's check this distance. So let's say the concrete cover, we are using the minimum concrete cover in this column, and it's equal to 1.5 inches from both sides, and the clear distance between the longitudinal bars can be calculated as total clear distance in horizontal direction between the longitudinal bars is 18 minus 2, deduct the concrete cover from both the sides, and then deduct the dia of strip from both the sides. 2 into 3 by 8, and then deduct the dia of longitudinal bars. So there are 3 bars. We need to deduct the dia of all the bars, and the dia of longitudinal bar is equal to 7 by 8, and this is equal to 11.625, and 11.625 value is twice the clear distance between the longitudinal bars. So this is the distance from here to here. In addition to that, it includes this distance. So we need to divide it by 2 so we can get the single clear distance between, or clear spacing, in between the longitudinal bars. Let's call it clear spacing. And this is equal to 5.8125. So clear spacing is equal to 5.8125. Let me draw that again. So this is the column. These are the longitudinal bars. We have one tie running like this, and the other one connecting these not laterally supported bars. And now if I draw the elevation or the profile of this column, so these are the longitudinal bars, number 7 bar, and these yellow lines indicate the ties, number 3 bar, and the spacing between the ties is equal to 12 inches. And we are done with the design of short rectangular tight column. Now let's move on to the next one. And now let's design a triangular tight column. And the interesting thing to note here is that I myself am designing this column for the first time. So let's see how it ends. And furthermore, let's design a triangular tight column which is an equilateral triangle, which means that each and every side is equal. Alright, so the area of such triangle, equilateral triangle, is equal to root 3 upon 4a square. And if you equate this area of triangle to this AG 207.07, you can calculate A from here. And A from here is equal to 21.86 inches. So let's take it around, approximate it equal to 22 inches. AG is equal to root 3 divided by 4, and A equal to 22 inches. So 22 to the power 2, and it's equal to 209.578. Now to calculate the value of AST, AST is equal to 3.99 inches square. Let's calculate the number of bars on the basis of this area of steel. And now we will calculate the number of bars, and the number of bars is equal to AS over AB. AS calculated is equal to 3.99 inch square, and let's assume that we are using number 9 bar. And number of bars in this case is equal to 4.01, which is approximately equal to 4. And notice that we have a triangular shaped column. We have to provide bars at every corner. Well, where do we provide the last bar? Well, if I provide it here, it's unsymmetrical about this line, and if I provide it here, it's unsymmetrical about this line. So I have to arrange the bars in such a way in the column that they are placed symmetrically. So if we talk about previous columns, let's take the square column for instance. We placed bar at each and every corner, and these bars are placed symmetrically about these lines which are passing through centroid. And in the case of rectangle, we placed bar at each corner, and then we placed 2 bars here, and these bars were also placed symmetrically about these lines which are passing through the centroid of the cross section. Now, how do we deal with this problem here? Well, we can use combination of bars. For instance, we can use 3 number 7 bar plus 3 number 8 bar, and this gives us an area equal to 4.16 inches square. Now you can see that this value of AST used, if I use this area of steel, then it's closer to the area of steel calculated from the formula, which is economical. And if I use, let's say, 6 bars of this dia, the area of steel used will be 5.96 inches square. So you can see the difference. If I use this area and it's closer to the area of steel calculated, it's economical, whereas this one exceeds it by 1.96 inches square. So I will use this area, and we will place bigger bars at the corners, 3 number 8 bars, and smaller bars here at the midway between these bars, 3 number 7, and A was equal to 22 inches. Now what about the spacing of ties? The spacing of ties will be used by checking 3 conditions, that is, and taking the least of these 3 conditions, that is 48 dia of tie, 16 dia of longitudinal bar, and the last one is the least lateral dimension, which is A equals to 22 in this case. You need to check them and pick the lowest value from these 3 values. And furthermore, we also need to check the clear spacing between the longitudinal bars. If it's greater than 6 inch, we need to provide additional tie. And in this column, you can provide tie in this manner. And if additional tie is required, you can provide tie in this way. And we are done. Thanks for watching till the end, and take care.